Dear students, Bismillahirrahmanirrahim. Welcome to our virtual session of week 6 of Introduction to Databases. If you can listen to me properly, please raise your hands. Okay. So in today's session, we are going to proceed from the slide we left. We'll be talking about some of the ER notations, which we didn't study in our face-to-face session. And then we'll be working on an example of designing an entity relationship diagram. So let's proceed from the slide we left. Okay. So we were talking about schemas corresponding. We talked about three relationships like specialization, generalization, and aggregation. And I told you that if we go back, I told you about specialization. I said that it is a top-down design process in which we designate subgroupings within an entity set that are distinctive from other entities in a set. These subgroupings become lower-level entity sets that have attributes and participate in relationships that do not apply to higher-level entity set. And this is depicted by a triangle component labeled ISA, which is a relationship. For example, instructor is a person. So instructor is the sub-entity, person is the entity, and instructor is having certain unique features which are not included in person. So lower level entity set inherits all the attributes and relationship participation of the higher level entity set to which it is linked. And we mentioned specialization in this way, like a person entity is divided into specialization, employee and student. Now if we say employee, that it means the employee has all the attributes of person plus salary. Similarly, a student has all the attributes of person. Student has ID, name, address, and total credits. So the employee is a specialized entity of person because every employee is a person, every student is a person. Similarly, if you specialize this entity employee into further specialization, instructor and secretary, then instructor has an attribute of rank, which is, so this is a special attribute unique to instructor. So it means every instructor is an employee and is related linked with the is a relationship, which is represented through this hollow triangle, and then employee is a person. So an instructor will have attributes of rank, salary, ID, name, and address. Similarly, a secretary will have ID, name, address, salary, and hours per week. So when we look at it in a different way, a bottom-up approach, then we call it generalization. We combine a number of entity sets that share the same features to a higher level entity set. Specialization and generalization are simply invariants of each other. They are just opposite to each other. They are both represented through the same way. In the same way, hollow triangle looks like an arrow. So they look similar. And these are both terms of these terms are used interchangeably. Then we talked about another relationship as a kind of relationship is aggregation. Like when we, for example, if you consider terminal relationship project guide, which we saw earlier. So if you want to record evaluation of a student by a guide on a project, so you have to sum up, you have to collect all the data the data from here, like instructor, student, and project, and evaluation for relationship, and then you will have an evaluation. So this can be depicted in this way as well. The following diagram represents a student is guided by a particular instructor on a particular project. A student, instructor, and project combination may have an associated evaluation. So all of three are merged up over here, project, instructor, and student, and they are placed in a box, and then they are having a eval for relationship and then an evaluation entity. So when we want to have schemas to represent aggregation, we create a schema containing a primary key of aggregated relationship, primary key of associated entity set, and any descriptive attributes. For example, if you want to define evaluation for relationship, you can have student ID, project ID, instructor ID, and evaluation ID all summed up in this relationship. So the schema for relationship will be defined in this way. Now, this is a summary of symbols used in ER notation. You represent entities sometimes through a box like this, and sometimes you represent it in this way, like you mention entity and in the above rectangle, and then you mention all the attributes over here. So when you mention attributes, you like the entity is simple, you mention it as simple A1. If it is composite, you mention it as A2 and then A2.1, 2.2 in this way. The multi-valued is represented through brackets, and derived is represented through a parenthesis after its name. For example, we previously saw age as a derived attribute. Then you represent relationship sets through this symbol, and if a relationship involves a weak entity set, then you represent it with a double boundary of this relationship. And if there is total participation of an entity in a relationship, you mention it through these double lines. Like relationship is linked with this entity, it means all the entities of this entity sets are participating in this relationship. Then if you want to represent the primary key of in an ER diagram, then you underline that attribute, and this discriminating attribute of weak entity set is represented by dashed line beneath that attribute. So, and to represent relationship, the many-to-many relationship is represented in this way, one-to-one in this way, many-to-one in this way, and sometimes you can attach cardinality limits in this way, like 1 to h. Sometimes you want to indicate certain roles, so you can mention role name over here, and you can have a role which is a role indicator. So if you want to mention the name and the role of an entity in the relationship, then you can mention it over here. If your entities are having is a relationship, generalization or specialization, they mention it in this way. Or if you want to mention about disjoint generalization, you mention it through a combined arrow, and then if you want to mention total generalization, then you mention it through in this way, and you can mention total along with that. And this is another alternate rotation. Instead of writing like in this way, you wrote all the attributes of the E entity in this way. So another approach is to write an entity and all the attributes in this way. So we have seen such kind of notation in an example we did it in our previous virtual sessions. So I asked you to understand the diagram. So this is an alternate notation of writing this. Weak entity sets are represented through this double border rectangle, generalization through this, and total generalization through this notation. And according to Chen, the alternative notation for many-to-many is this. For one-to-one, we write it in this way. For many-to-many, you write it in this way. For participation, total participation, you mention it in this way. Another notation is to use these symbols. So this is used for many-to-many. This is for one-to-one. This is many-to-many, and this is to represent the participation, total participation or partial participation. So here the participation in our of E1 is total and E2 is partial. So the total participation is mentioned through this symbol, and partial participation is mentioned through this. So this is another notation. So you can use any of the ER notation, but once you are using one notation, then you should stick to it. You should not do it like you are using one notation in one diagram, one part of a diagram, and another in one part of the diagram. If you are choosing, for example, Chen's notation for ER diagram, then you should stick to it. You should not mix up all these notations. The unified modeling language has many components to graphically model different aspects of entire software systems. And UML class diagrams correspond to ER diagram, but several differences. So you mentioned your ER diagrams have many similarities with the class diagrams, but there are many differences as well. So these are the similarities which are mentioned over here. Like you can mention entity, attributes, and multivariate derived in this way, whereas in case of UML, you have a class which has which has simple attributes and methods, and you can use prefixes such as plus, equal to, minus, equal to, private, protected, etc. So these notations are not there in entity relationship, whereas you can use it in your class diagram. Similarly, there are differences in notations of entity relationship and UML class diagrams. Like in ER diagram notation, your entity 1 is related to entity 2, entity 3, which is an ternary relationship, like ternary in this case. So the notation is quite similar in your UML as well. So when you write overlapping generalization, this is written like this. In entity relationship and its UML, it is written like this. This relationship is mentioned in this way in both. So this is end of chapter, and these are the different figures which are used in this. So I'm giving you a few minutes to just go through the contents we have just read, and please ask me if you have any question. Okay, students, can you listen to me? Can you hear me? Okay. Okay, I forgot to enable your chat permissions. Okay, now these are enabled. Okay. So this is a question for you now, that so you have to make an entity relationship diagram for this. A university consists of a number of departments. Each department offers several courses. A number of modules makes up each course, and students enroll in a particular course and takes modules towards the completion of that course. Each module is taught by a lecturer from the appropriate department, and each lecturer tutors a group of students. Make an entity relationship diagram for this scenario. So I want you to first identify all the entities, identify the relationships, identify and make an entity relationship diagram for this. Okay, is it understandable? Are you getting it? Or if you have any question, then you can ask me now. So I'll give you around 10 minutes to do this activity, and then I'll be back and I'll explain how this was done. Any question? Any question about this question? Okay. Okay, students, then take your time. It's around 6:30, and I'll be back at 6:40, and I want to know that what you have done, and how you have identified activities, what are the attributes you have identified. So take your time, spend some time, and draw the ER diagram, and hopefully you'll come up with something good. Okay, students, I hope so far you have identified the entities from this example. So, if you can see from the text was a university consists of a number of departments. Each department offers several courses. A number of modules make up each course. Students enroll in a particular course and takes modules toward the completion of that course. Each module is taught by a lecturer from the appropriate department, and each lecturer tutors a group of students. From all this text, we first identified which are the things in it which have certain attributes. So the underlined words in this text, like department, courses, modules, students, and lecturers, are the entities in your entity relationship diagrams. So from this text, first of all, before going into more details, I have identified all the entities. So first you have to identify the entities from this text. Department, course, module, student, and lecturer are entities, right? So after identifying entities, now you identified what are the attributes of these entities. For example, every department has a department ID, its name. So I want you to now move on. So the entities are department, courses, make boxes for this, modules, students, and lecturer. Okay. Now identify attributes of all these entities. Yes, these are like that. You can identify those. So first identify attributes and then identify relationship. So take your time. I'm giving you more 5 minutes, and then you identify all the attributes and then identify the relationships. Is it clear? Any questions so far? Okay. Okay, now I'll be back after 5 minutes to tell you about attributes. Okay, students, so can you tell me what are the attributes you have identified for each of these? So what can be possible attributes for department? So who will tell me that what are the attributes of department? So Arwa, can you tell me? Arwa, roll number S120003460. So are you there? So can you tell me what are the attributes of department? Okay, Arwa is away. Someone else? No, I'm not like this. You can the departments can be the ID, the number of department, or you can say the number of faculty members in the department, number of sections in the department. Yeah, you said number of sections. Number of courses offered in the department. Yes. And if we talk about courses, what can be the attributes? About courses, course ID, course name, or course title, course credit hours. No, date cannot be. Number of credit hours, the prereqs. Okay, so these are the attributes about this. And the number of modules, if we talk about modules, because the number of modules break up each other. So now module ID, module title, offered to whom. So these are the attributes for module. Then student ID, registration number, number of credit hours, etc. Then same information can be recorded for lecturer, ID, name, and department, from which department he or she is belonging, the salary, the scale, or etc. So these are the attributes which are identified. Now, when you have to identify the relationships, so to identify the relationships from this, what you see is you read this text again, and from this text, you come to know that there are certain verbs being used in. For example, each department offers several courses. So now this offers refers to a relationship. Then a number of modules make up each course. So make up is a relationship. Students enroll in a particular course. So enroll in is a relationship. And take module. So take is a relationship. So you see all the verbs. Each module is taught by. So taught by is a relationship. And then a lecturer from the appropriate department. Lecturer from the appropriate department. So this is the relationship. And each lecturer tutors a group of students. So tutors is a relationship as well. Okay. So now you have identified all the relationships. And after identifying these, you model these relationships in the diagram. For example, if you talk about department and courses, you said each department offers several courses. So it means there is a relationship of offers between department entity and courses entity. Okay, Arwana, no problem. If you can hear me, that's okay. Okay, So now there is a relationship between department and courses of offers. Now we have to see that what kind of relationship it can be. It can be one-to-one, it can be one-to-many. Now it's written that each department offers several courses. So it means it is one-to-many relationship. From the department end it will be one, and from courses end it will be many. Then there is a relationship between modules and courses, because it is written that a number of modules make up each course. So it means number of modules makes up each course, and each course has many modules. So if you read it in different way, so you can have a make-up relationship or includes relationship. A course includes module, and a module is included in a course. So it will be many-to-many relationship, because number of modules are there in each course, and each has several modules. So it will be many-to-many relationship. And then comes the enroll in relationship. Students enroll in a particular course. So many students can enroll in one course, and you can have it this way as well, that many courses are enrolled by one student. So it will also be many-to-many relationship. Then you said that students takes modules towards the completion of that course. So it means there is a relationship between student and module as well. So previously it was between student and course. Now takes relationship between module and student. Then taught by relationship between module and lecturer. So teaches or taught by. So lecturer teaches module. So one lecturer teaches many modules, but one module is taught by one lecturer only. Okay. So if it is from module to lecturer, so it will be many-to-one, because many modules are taught by one lecturer. Then comes the relationship between lecturer and students. And before moving to that, we can see that lecturer from the appropriate department. So there is a from the relationship between departments and lecturer. So one lecturer belongs to a department. So you can have an employees relationship between it as well, like a department employees lecturer. So a department can employ many lecturers, but one lecturer can be employed by one department. So if it is from department to lecturer, so it will be one-to-many. And then comes the tutors relationship. Each lecturer tutors a group of students. So one lecturer tutors many students, and one student is tutored by one lecturer for a particular course. So you can make an entity relationship diagram very easily in this case. So what we did is we first identified all the nouns from this text and called them as entities. Then we identified their attributes. Then we picked up all the verbs from this text and called them relationships. And then we made an entity relationship diagram and modeled all these relationships in the diagram. So just wait for a second. I just want to show you a complete entity relationship diagram for this. So I have picked this example from web. So you can see what you will have to explore for some time to see the exact solution. So I'm pasting it over here for you. So that this is the entity relationship diagram. Which will come up finally. So is it visible to everyone? So this is the solution. Okay, so this is the solution. Each department offers many courses. One course includes many modules, and one module can be included in multiple courses. Each module is taken up by many students, and one student can take many modules. One course contains many students, is taken up by or enrolls in many students, but one student enrolls in one course. So if we are saying that it works, but we can have many relationship as well, because student can enroll in many relationship too, many courses too. Then each lecturer tutors a group of students, and one student is taught by one lecturer. So I'm talking about a single course right now. So that for that course, one course is taught by one lecturer. One department employs many lecturers, but one lecturer can belong to one department only. So from department to lecturer, it is one-to-many relationship. So this is the ER diagram. So in this ER diagram, I have not mentioned the attributes of these entities, but we can mention. And remember, this is one of the notation which is being used to mention the many-to-many or to draw an ER diagram. We can have many other notations as well to draw. So, but you should be familiar with all the notations for ER diagram. So whenever you see, because in exams you will not be sticking to only a particular notation, we can use any notation. So you should be familiar with all the notation and you should understand what each of the symbol means. So that is an example for you so far. And now I want to give you another practice exercise to you. And I want you to make its ER diagram on your own after the session. And this will be for your practice. So we can add the text here. I'm sorry for the inconvenience caused because the delay caused, but I want you to give you best example. I want to give you best example to solve and work on, from which you can learn maximum. So this is your practice work. I don't know what's the problem with it. I want to do full screen, but it's not working. So can you see here? Can you see the question? So can you see the question? Okay. So this is a question for your own practice. A database will be made to store information about patients in a hospital. On arrival, each patient's personal details, name, address, and phone numbers are recorded where possible, and they are given an admission number. They are then assigned to a particular ward: accident and emergency, cardiology, oncology, surgery, etc. In each ward, there are a number of doctors and nurses. A patient will be treated by one doctor and several nurses over the course of their stay, and each doctor and nurse may be allowed with several patients at any given time. So from this text, you first of all have to identify all the entities And once you identify entities, then you will have to identify their attributes and their relationships. So this is your practice. This work is for your practice. So try to make an ER diagram for this. So since the session is recorded, so you can view this text later and work on it. Okay, any question from the contents we just studied or for the concepts we studied in class? Okay. Okay, students, thank you very much. So even after this session, if while making ER diagram, if you find any question, you can always send me an email. There is no assignment during this week. You will get the assignment of this course in the coming week, in week 7. So in this week there is no assignment. Okay, thank you very much. I'm going to turn the microphone off.